Hello. So, this video is purely me having a way to express myself like this, like talking. Doing a vlog in a way is giving myself that kind of socialness in the sense of me sharing something, and it's really just purely for me in this moment because I just want to talk about math, everything that I've been learning within the GRE studies I'm doing, and particularly just trying to see what are the key things that I, let's say, learned that I didn't know. And so this is more a point of as if there is someone here to listen to me and sharing this kind of stuff, which could be very, let's say, boring because it's about math. And I don't really necessarily have anyone here at all to do that. So this is a cool way of just, sharing. And it also reinforces my learning as well. So just bringing everything here in terms of math. So there are certain things that I was memorizing that are interesting that I didn't know, which was that 0 is an even number. The even numbers start with 0, so it's 0, 2, 4, 6, 8, 10. The odd numbers start with 1, 1, 3, 5, etc. So I didn't know that 0 was even, and there was a question that had an answer that would require knowing that 0 is even, and that's how I learned that fact, was by getting that question wrong and looking it up. Like, how come, why was it wrong? Because 0 is an even number. So that's interesting. Something else that's pure memorization is that with prime numbers, 2 is a prime number. And for some reason, I just didn't memorize that or really know that. Prime number is any number that is only divisible by itself in 1. And so what I decided to do is just memorize the first prime numbers. So they are 2, 3, 5, 7, 11, 13, 17, 19, and 23. So I just memorized that just because chances are questions on the exam will only have like those first prime numbers if they're going to be related to any question on the exam. So I won't have to think about, oh, is this a prime number or not? Because I never really memorized that list. I never really needed to. So I memorized that. The other thing is 2 equations, 2 formulas that I just have to memorize just to know so I can use it right away. The first one is combined work, which is an equation that if you memorize it, it makes this type of question like answerable super quickly, and I really don't know how they could expect anyone to answer these questions without memorizing these equations because they're not necessarily intuitive. It was kind of funny too how the first time I was answering these questions, trying to figure them out by myself and using the answer key that had explanations in the back of the book, it didn't really fully clearly explain the formula in this one book. But in the second book that I have, another workbook, it did explain it. And I even discovered another use for it that wasn't in the book. And the book was actually saying like, oh, this is a very difficult problem, but you just have to use the formula for this, but just in a more creative way. The formulas combined work when you have, for example, 2 different pumps working at a certain rate. The amount of time that it takes to do something, let's say one is 6 hours or another one is 3 hours, and then together the amount of time that would take if they're both working simultaneously. Those are the variables for the equation t, which stands for total time it takes for both objects or persons doing the work, the total amount of time it takes to working together. So that's t divided by a, which is for the first person or object, plus t divided by b, which is the second object or person, equals 1. And that equation is the same thing as a times b divided by a plus b equals t, total amount of time it would take. So in these kind of word problems in the GRE combined work, just knowing this formula and just plugging everything in, you get the answer very quickly. And sometimes you have to be a little more creative, in which case you use ratios in combination with this formula, but I can work with that, with the ratios in the formula. For example, if a pump takes 5 hours to empty out 10,000 gallons of water, then in 1 hour it will empty out those 10,000 divided by 5. And then that gives you the rate for that one pump. What was interesting is there was another question on one of the exams where on his workbook exam, where it had 2 pumps working at the same time and a third valve that was emptying out the water at a constant rate as well. And then there, I just made that third pump C and made that negative and plugged that into the equation, the formula. So it was like t divided by a plus t divided by b minus t divided by c. So it was just negative. And the answer key in the back did not have that answer as a solution, and I answered that question super quickly. And that was the one they were saying that, oh, this is one that's very difficult to do. But you just have to use a little common sense and just make that negative. And that was the answer that I got really quickly. So that answer key was bad in the book. And these are people writing these books, right? So people make mistakes or people don't necessarily know. But, you know, you get lucky, I guess. You just try something and it works. But, so that's one formula. Another formula is distance. Is simply to memorize that when you're calculating the distance between points in a grid, with x and xy grid, like 2, 5, was the distance between 2, 5, the point 2, 5, and the point 3, 8. And it's just a formula of square root of the two x's in the 2 points subtracted from each other, square that, plus the y's subtracted from each other, square that. That whole thing is a square root. So you have the 2x's squared subtraction, adding to the 2 y's that are subtracted from each other, and you square that, and the whole thing is a square root of that. And that's just based off of the Pythagorean theorem, which is just a triangle, trying to find the hypotenuse of a triangle. That's really what the equation is based off of. That's something just to memorize and just use right away. There are a few other things that I was memorizing as well. I'm not sure if they'll actually appear in the GRE. Stuff like how many feet are in a mile, like 5,280 feet in a mile. Another thing is simply strategies, such as making sure to draw a number line very quickly whenever I'm dealing with comparisons between variables and situations where there's a comparison symbol as greater than or less than, because it's just quicker just to draw a number line instead of thinking about it in my head, and that helps me just see the answer super quickly. That's just a strategy, is to draw a number line where it's applicable. And another one is how to work with patterns and series of patterns, or those equations that are for those kind of patterns things. And little things like paying attention whether it's even or odd, or very important is whether the problem or the words include integer as a part of the problem at all. Because the word integer is a whole number, which is very specific because some questions will trick you where it will not mention an integer. And so if you have a solution that involves 1.1 or 1.2, which are not integers, you may get that wrong because you only decide to use integers like 2 or 3 or 4 or 5 when you're plugging into the equation. When there's actually, if you plug in 1.1, 1.2, they act very differently when they are squared, because 1.2 squared becomes smaller, it becomes like 1 point, I don't know, like 1 or something. Whereas if you square a 2, it becomes bigger, it becomes 4. And a lot of these equations involve comparison, so it tricks you if you're going to use anything that's like a fraction like that, especially like 1.1. That's very tricky. I would say very annoying as well. Even I would say it's stupid as well. But that is what it is. To focus on the point of whether it says integer. It's like, when I see the word integer, it has to be like red lights flash on. Same thing too when I'm dealing with rounding. Rounding can be super specific. This can be a very common mistake for moving too quickly where it says round to the nearest. And so that's very important. And there's little things like we're dealing with the absolute value symbols to make sure when solving that to do both the negative version and the positive version when you're solving the two different possible answers, and to flip the greater than less than symbols with that. If it's negative, you flip it. What else? Another thing is working with number of combinations. There's two formulas. One where the order doesn't matter. Use a formula factorial n, which n stands for the total number of the group. Let's say you have a group of 8 and you're picking 4 people from 8. How many combinations of people can you pick? And in a case where the order does not matter, then you use the equation of factorial n divided by k factorial, open parentheses, n minus k factorial. This is where the order does not matter, and the k stands for how many people you're taking, which in this case you're taking 4 people out of the 8. And if you do the plug-in for the equation, then you get the answer. And and also has to remember or learn what factorial was, which is simply factorial of 3 is 3 times 2 times 1. Factorial of 4 is 4 times 3 times 2 times 1. So simply that number you start with, multiply it against each number minus 1 until 1. So factorial 8 is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And memorizing this equation of the number of combinations where the order does not matter is absolutely essential. You just have to know it. If you don't know it, then you're screwed. So you have to know that equation and use it, and recognize when to use it. And also how to use the formulas when the order does matter, which would be the same equation except it would be n factorial divided by n minus k factorial. So it gives you more combinations because it's more restrictive. Another thing is to use that combination number of outcomes, number of possible combinations. Use that formula in conjunction with using it within probability, which is what also a point of thing that's kind of makes me nervous in the sense of you never know what you get. I'm not fully 100% know everything probability. That's one of the things I've been learning as well. How to use that combination formula in relation to probability, where you're dealing with probability is simply the events that are for the probability you're working for, divided by the total outcomes. So sometimes you have to plug in that combination, the number of different combinations, into the events for a probability, which is kind of interesting and kind of very, let's say, tricky. And because a lot of the GRE, they try to like combine different things together. For example, combining ratios with algebra. Now that was also tricky as well, to combine those two together and to recognize that when I'm dealing with ratios that I have to use algebra in order to solve. That was the key there to learn as well, is to recognize when I have to use what strategy. Another equation is dilution, which I'm still working on, but I was able to kind of work with it yesterday intuitively, where I'm going to have to continue working in that more depth, but in a very simple version is that when you have a mixture of a certain quantity of liquid, let's say 5 liters, and a certain percentage of that liquid is a certain substance, let's say 7% alcohol, I guess. So 5 liters, 7% alcohol, and then let's say add 2 liters of water, just pure water with nothing else. How much percentage of that new liquid is now alcohol? So you have to add the 5 liters to the 2 liters, it gives you 7 liters. That's the new total, so you put it on the bottom of the ratio, 7, or the percentage, however you want to put it. I think ratio would be better in this case. So 7 on the bottom. On top, you need to put the 5, so it's 5 out of 7. And you use that and you multiply that against the 7%, and that gives you the new percentage. Just double checking now, making sure I remember it correctly. Yeah, that's right. Again, that's something that I was just working on, and that's something that I need to focus on, because there are some more difficult word problems that uses dilution, as it's called, and I need to test myself on that more, practice that more. But that's one of those things which you read when you do the exam, that you just know when you read that it has to do something with dilution. You just know it, and you have to use that certain strategy of some sort, because it get more complicated. So there's that. Other things to memorize and remember was the 2 different kinds of triangles that are 3, 4, 5 ratio, where the 2 legs of a triangle is 3 and a 4, and the hypotenuse is a 5, and any ratio of that is valid for a triangle. So if it's 6, 8, 10, that's also valid measurements for a triangle. Where if you ever see, like, if you know that one side is 6, one side is 8 of the legs of a triangle, you know 100% sure that the hypotenuse is 10. You don't even need to think about it. You just know it. So those kind of things help you do it faster, do that questions faster, and sometimes even necessary to solve it. Well, yeah. And other special relationship is the 30, 60, 90 triangle, where you know 100% that for a right triangle, before when I was talking about triangle, I meant a right triangle. These are both 3, 4, 5 is for a right triangle. And this 30, 60, 90 degree triangle is also for a right triangle. The 30 degree angle, the side that it faces is a ratio, let's say 1 or an x. And the 60 degree angle has a ratio of x to the square root x times the square root of 3. And the hypotenuse is 2x. So that also is this very special relationship with the angles and the sides. And that was something that I had to know for a certain geometry question, which you cannot answer that without knowing that fact. So that's another example, something you just have to know, you have to memorize. And also another example would be how the angle is circumscribed into a circle where it's on the tip of the triangle is on a point of the circle, and the two ends meet at the 2 points of the, let's say, diameter, which also are at the end of the circle. That angle would be a right triangle. That diameter would be the hypotenuse. Same thing if you have an angle where it has nothing to do with the radius, it's just if a point starts at the center of the circle and you go to the edges of a circle anywhere you want, and from those 2 points that are edge of the circle, if they go to the top of the circle anywhere, then that angle up there is 2 times the bottom angle. And that's a different relationship, and that was a different question that involved that as well, where you just had to know it. If you didn't know it, you got the question wrong. And these are all questions that I got wrong on the test. That's been my focus, is what doesn't come easy, which I didn't immediately know what to do. And there's little other things I just kind of memorized to pay attention to, like if a graph is a proportional bar graph or like a percentage bar graph, they pay attention that the parts of the bar graph is of that structure where it's not like a regular bar graph. You have to pay attention that each section represents a certain proportion, which is what the bar graph is telling you. That can be tricky if you don't pay attention to that and you answer a question that involves using the correct proportion of the data set, of the sample. And then other little things like paying attention if it has to do with or one mistake I made, which is I was like, oh my god, was I did 10 times 10 divided by 20. I canceled out the 20 and I canceled out the 210 because I guess from my head I was doing like 10 plus 10. So that was a big mistake. So I had to like remind myself, 10 times 10 divided by 20 does not cancel out to 1. So stuff like that, just like little things that I was doing immediately in the moment, which I didn't really know. I did the wrong thing. So just correcting that. And other things like probability, if you want some event that is at least 1, let's say at least like something like that. The key word is at least. Then you could do 1 minus everything else that is not the at least. That'll give you the probability for the at least. That's interesting. So yeah, that covers everything that is immediately here, like all the major formulas that I just did not know, and that I had to like look up, kind of like discover and learn, and these little things to memorize, like that 0 is an even number, and also like learning and pay attention to the fact that whenever you multiply uh, a fraction like 1.5 or zero point 0.5 by itself, it always becomes smaller, but it's always proportional in that 0.51 multiplied against itself 0.51 and zero point 0.5 multiplied against itself 0.5, those two will still be in the same order, but they will both be smaller. So just to pay attention to those kind of facts, to not get that mixed up, and just know it immediately. You don't have to think about it, you just know. Because a lot of this test is about time. You don't have time to think about it deeply. You try to figure it out. You just have to know the rules already. And that will save you time. That can help you focus on doing it right. And yeah, so that's good for now, I think. Wow, 26 minutes. Anyway, so yeah, thank you very much. Bye.